Right, hello and welcome back to another video. So this week we're going to be having a look at a question that was sent in by one of my viewers, so thank you for that. And as always, if you have any questions, please do send them in. I'll try and help, and if they're particularly interesting, I might make a video about them. So this was the initial question. We're not going to be remaking this whole effect, but specifically, how can we fire out multiple projectiles along an arc with equal spacing? So not fully random, but always the same gap between them. So quite an interesting problem, one that we can solve straight out of the box with Niagara's modules, a little bit of maths. And so, yeah, let's get started with that. So before I approach any of the problems like this, I like to do a little drawing or a little sketch just to make sure that I've got everything clear about what we're trying to do. So if I jump over to Photoshop, that's kind of what I've got here. Obviously very representative, but here is our emitter. We're firing out multiple projectiles, and we want to make this scalable and parametric. Very easy to sort of like black box this and put in, say, the data for 5 projectiles, but suddenly your level designer or gameplay designer changes the amount of projectiles. You want it to be data driven and scalable. So we're going to have a number of particles, and let's just use a different color to make it clear. We're going to have a number of particles, so I'm going to call that n. And that in this case is 3, in the other image it was 5, and we're just going to make that kind of work for all cases. We're going to have a primary direction. Let's try and do a straight line, and that's going to be our direction of travel. I'm going to call this V for direction vector, and we're actually going to break this into 2. So we're going to have a direction, we're also going to have a speed, and so we're going to kind of separate the 2 things down. Again, nice and easy then for designers to change things. The direction's probably coming from code where you've targeted with your mouse, and then speed's going to be driven by the sort of leveling of your character's ability. So nice to have those as 2 separate things. And then the last thing we need here is the angle. Now if I put in a sort of angle here, in this case, again, the angle is going to want to be an input that we put in, and it's going to want to scale based on what we put in here. So that should be the data that we need, and then we can build up based on these and how Niagara spawns the particles to get the effect we want. So here we are in Unreal. I'm just going to start a brand new Niagara system from the empty template. So just really simple, and going to let us build this up without any extra bits in there. Give it a sec to compile. There we go. NS class, and I've just called this arc projectile because that's what we're doing. Projectile. There we go. And if I open this up, there we go. I'm going to need to see something. So I'm going to go in here to my, where are we? Emitter update. And I'm going to do a spawn burst instantaneous. And we'll look at some different spawning, but for the example that we're doing here, spawn burst is going to be what we want. And I'm going to make this spawn count into a parameter. So 2 ways to do that. Either pull down, type in user, and we can kind of promote it to a user parameter. And there we are. This is now called spawn count up here in our users. Or you can just create them directly up here. So either works. And if you want to edit that value, if we go into our projectile system parameters at the top here, we've got our spawn count. So I'm just going to set that to 5 because that was the example we had. Cool, fine. We've got 5 projectiles. Well, I don't want to see sprites. I'm going to delete these. I'm going to add a mesh renderer. And I'm going to use in here in the mesh, where are we? Meshes 1, the arrows. So SM arrows, if we just open this up, it's a little bit big, but we can scale that down. It's a default mesh that comes with the engine, but it's a really useful one. So it has a very clear directionality to it, and it faces along the x-axis, which is important for velocity aligned meshes. That's the default axis that gets aligned with velocity alignment. And it's also got 3 meshes here, so if we wanted to, we could see spin and things like that. So it's quite a nice debug mesh for this kind of velocity aligned effects. Obviously you can make your own, replace that. It's not going to change anything for what the visuals are based on sort of the projectile movement, which is what we're doing here. So that's what I'm going to use for now. And if I go back to my system, oh, it's very laggy today. or that has crashed entirely. Oh, there we go. Not sure why that's taking so long, but there we are. So we have our meshes firing out, and I'm just going to scale them down a little bit. So here in initialize particle mesh size, scale uniform 0.1. It's a bit more manageable size, and we're going to add some velocity to these. So in the emitter particle spawn, here we are. If I type in velocity, we get the add velocity, and we don't just want a linear movement. Oh, yes we do. Where are we? We don't just want the okay, let's just fix the dependency first. So because we've added a velocity, we need to have a solver here, so we're going to add the new solve forces and velocity. There we go. And we do want linear movement, but just for now I'm going to do it from point, just to have a look at what we're going on here. So here we are firing out our particles in a sort of radial pattern. If I just up the velocity a little bit, and I want them to be velocity aligned, so facing mode, velocity. There we are. Now this would be fine if we were just firing out from a point, but what we want to do is fire out a single direction and then sort of have an arc to that. So if I go back to add velocity, and let's change it back to linear, we have an input here for velocity. Well, first thing I'm going to do is change it to be in the x-axis. That's the way I want my sort of projectile to fire. And I said before, we're going to split this into two. So rather than having a single value, I'm going to do a velocity, well, we've got speed there, but we'll be able to do it here anyway. Velocity multiplied by float. So vector multiplied by float, so I can have a direction vector in here and then a float for my speed. So again, going to make these user parameters, and we're going to call this direction vector, and then let's do a new user and speed. And again, remember, once they've been created, we need to set them over here. So the direction vector in this case is just going to be x, and the speed, let's say 500. Now what we want to do now is, for each of these particles, we want to take them and rotate the vector that they're moving in by an angle. And so if I go into my add velocity value here, what I'm actually going to do is take a screenshot of what's happening in my effect using this thing here, the attribute spreadsheet. So I bring this into the screen. Here we go. What's happening, or what will happen, if I click capture, it'll just take a snapshot of all my particles and give me all the data relating to them. So the age of the particle, how far they've traveled, lifetime mass. This is all the data available to us here up in particles. And so if we scroll along, there's one here that's really useful, and that is right at the end, unique ID. So if I go back to my particle system, and let's go back to the start, and then just play and capture. There we are. So the first 5 particles that get spawned with the numbers 0 to 4. That's just how many, or a numbering system for how many particles have been spawned. And then this is currently looping. So if I play on a little bit more for a second burst and capture again, these now numbered 5 to 9. And we'll deal with the numbers going up later, but we're just going to assume for now that our particles have a unique ID of 0 to 4, and we're going to use that basically as a multiplier. So we know our angle, and if we're going to multiply the first one by 0, that's going to be moving along the same direction. The second one's going to be multiplied by 1, well that's going to be the next angle, then the next one's going to be 2, the next one's at 3, and because we're moving whole numbers up each time, we're going to be getting a sort of standardized arc length here, or gap between them, which is exactly what we want. So that's the idea. So how do we actually do this? Well, this vector, this is the thing we want to rotate. So that's the direction our particles are moving in. And if I replace that input with a rotate vector, there is a module or an input for this. And so we have the vector we want to rotate. Well, that's our direction vector here. And we can just drag and drop that in, or we can find it in the drop down. Either is fine. And And what we'll find, if I go back to here, if we do a angle of, let's say, 15 degrees on the yaw, I never remember which one of these is which, but we can just plug in values and see which angle we're moving along. Nothing's happened here. Now what's happening is the rotation rate, this is acting as like a multiplier. So the default setup for the rotate vector input is to do it sort of over time. And if I try actually and put this in my, okay, well, let's turn that one off a sec and let's try it in here. So we'll do velocity, let's do vector, see if we can show this somehow. Set new or existing parameter, let's see if this works. So if I take the particle velocity, particles velocity, and then if I take the rotate vector, particle velocity, and rotate around things, so I do need an initial velocity. Let's see how quickly that's going. There we are. So we can see here what the rotate vector is sort of set up to do. It's taking a input velocity, in this case the direction the particle's moving in, and then it's taking a yaw value, so it's rotating around the z-axis, and a rotation rate, so engine delta time. So as time is going forwards, the rotation is happening, and you can get this kind of spinning in a circle type particle. Obviously different angles will rotate around different angles or different axes, and that's what the module is designed to do. We're going to do some slightly different things with this. It's not giving me spin. It should maybe give me spin on there, but not sure about that. Anyway, what we're doing is going to be rotating around this angle, but we're not going to be using time. We're using particle spawn here, so we want an initial variation, but this just works as a sort of multiplier. In this case, it's animated, it's a value changing all the time, so we get animation. But if I just change this and let's say do a new local value, well, anything that is being put in, it's being applied every frame. So because we're in update, it's being applied every frame. So we're getting these very fast rotations. I put smaller values in, yeah, there we go. I'm getting constant rotations. But we're not going to use this as a sort of fixed value. We're going to do a fixed value based on each of the particles as they spawn. So hopefully that makes sense on what the rotate vector module is doing. Again, we're not using it at runtime, so I'm just going to delete that one. But if I go back to my velocity here, rather than my rotation rate here being delta time, if I make that a new local value again, effectively it's going to work as a multiplier, our rotation angle. So in this case, if I do 1, it's going to go off at 15 degrees. If I do 2, it's going to go off at 30 degrees. 3, 45 degrees. But obviously this isn't fixed for every particle. This wants to be different for each particles. But we have that. We have the particle numbers 0 to 4 for the first 4 particles being spawned. So what we'd like to be able to do is just plug in our particle ID here. But there's a problem. This is expecting a float input. You can see it in the tooltip. You can see because it's 3.0. But if I bring back my attribute spreadsheet, wherever that was, and I can just quickly capture. Why can I not capture a second? I've not got it selected, that's why. Here we go. If I capture this, if we go back and look at our unique ID, these are integer values. You can't have half a particle, doesn't make any sense. So the engine stores this as an integer, and it's very easy to convert from one to the other. All we need to do in here is then go into this bit here, rotation rate, and we're going to do a float from int, make float from int, and you should be able to see if I press play. If I put in 1 or 2 or 3, it's just converting that integer value to a float value, which you can then multiply by the other floats. And now we should be able to get our ID attributes. So return particle ID attributes, and we want the particle's unique ID. And if I hit space, restart this, what you see is we are getting close to what we want. Now there's a few problems with this. They're rotating from the center line. If you see here, if I put that back to just a local value, the direction, our straightforward direction vector is here. It's basically straight up the screen. But when I put that math in there, they're rotating around that point. So effectively, I go back to my Photoshop drawing. If I were to take this and rotate this, and let's rotate it, oops, around that point. Where's the pivot? I can't find it anyway. So effectively we're getting that. We're starting from this direction and we're rotating this way. Well, again, not quite what we want, but close. All we want to do is take the whole thing and sort of rotate it back by half of the total rotation, if that makes sense. So here we've got 3 particles and an angle of, let's say, 15. So if we take 2 gaps, so then we want to take 30, so we want to rotate the whole thing back by 15. If it was 5 times 15 is going to be 65. So we'd half that and move it back by 32.5, I think. Obviously, we're not going to do the maths. We're going to let the engine do it, and we're going to do it sort of programmatically. So we're going to do it based on the inputs that we've got. So taking this value, and we want to take the whole value here and sort of push it back by half of the amount. So if I take this make float from int, and what I'm going to do, I'm just going to right click and cut. And that'll put it back to the default, but it'll mean I can paste it back in when I change my inputs. So I'm going to do here a subtract float, and now I can take the first value A and right click and paste, and that's given us the same thing. So it's a nice way of sort of inputting values in, sort of data in. So here we go. We have our angle. Oh, just ignore that. We'll fix that in a second. And what we want to subtract, well, it's half of the total angle. So our number of particles, spawn count, and let's do it. Spawn count multiplied by our angle. Well, we haven't made that parameter. Here it should be this one. So let's promote that to a user. And we'll call this angle. And that is still set to 15. Okay. So here we want to have our multiply float. So our spawn count. Oh, another problem. What's going on with our spawn count? Well, it's an integer. So we need to do another conversion in here. So if we do float from int, if I could spell, make float from int. The int is the spawn count. Spawn count, and we're multiplying by the user angle. Well, we want half the user angle, don't we? So let's do another multiply float in there. So this one is now the user angle, and we want to multiply by 0.5. What have I done wrong? So our spawn count multiplied by that. Oh, wait a second. Don't need the angle in here. The angle is getting applied later. So in this case, my 5 for how many particles I've got, or my 0 to 5 wants to be actually from -2.5 to +2.5, if that makes sense. So if I just do that multiplied by 0.5. So got myself into a mess here. Make float from int spawn count multiplied by half. And I'm doing a subtract. So let's just reset that back. This here, I want to subtract 2.5 to, that's what I want. You can see here now we're getting the end result that we want. So it's the particle ID in this case. Again, ignore that. Is going from 0 to 5, and I want to subtract 2, 2 being 5 minus 1 over 2, so it is subtract float. This is our spawn count. No, let's do this. Oh, it's all got a bit wrong. Okay, right. Just had to do a little bit of debugging. So, where were we? So we have a particles firing forwards and then rotating. So we need to rotate the whole thing back by half the value of the total rotation. So basically putting the middle one back into the middle. So here we have our rotation rate value. So we have our unique ID, and what we're going to do is we're just going to copy this value and reset it, and we're going to do a subtract, and we're just going to paste that back into the A input. So we're subtracting nothing. If I were to subtract 2, you can see that's the result we want to do. So this is centered here. So we don't want to just input 2, that wants to be based on our number of particles. So in this case, it's going to be our spawn count minus 1 and then divided by 2. So 5 minus 1, 4, divided by 2 is 2. That gives us our end result. And the reason we do that minus 1 is just because we're counting by different values. So if I go back to our attribute spreadsheet again and just capture, is that the right one? It probably isn't. No, let's restart. There we go. This counts from 0 to 4, whereas this count up here, obviously we've put the value in and we've said we'd like 5, please. So you get an off by 1 error. Very common for these kinds of things, but quite easy to spot and then to fix. So I've just turned our performance on, don't need that. So here we are. So in B, we're going to do a, it's actually going to be a multiply float. And then in here, we're going to do a subtract. And let's do a float from int. No, wait, this is in, yes, it is an int. So float from int, and then int, subtract int. So it's going to be our spawn count minus 1 to get it to be the right numbers, and then multiplied by a half. And what you should see now is we get our 5 particles centered around the direction vector, with user parameters to control things. So if I went up to, let's say, 9 particles, you can see it just widens my arc, has more particles, so maybe we need a lower arc for that, and we can obviously change the direction vector. So in this case I could fire them in the Y direction, and that would work as well, and we can make them slower and whatever we need. If I just put these back to our X direction, we can see here this is working, no problem, but you've probably spotted this already. The second set of particles that fire are firing further round, and that's because the second set of particles, if we look at the ID, I go back up here and select the spreadsheet and capture. You saw this earlier, but the ID count carries on. Well, that's fine, that's what we expect, but what we want is to sort of reset that number. And the way we do that is with a modulo command, sometimes sort of used the percentage symbol. Basically it says what's the remainder after division. So in our case, if we take our values 0 to 4 and then we modulo with 5, what will happen is, well, the first values will stay the same, but with the second values, if we take 5 and divide by 5, divides exactly, there's no remainder, so the remainder is 0, which puts a value of 0 in our first particle again, which is what we want. For a value of 6 modulo 5, well, it goes once, and then the remainder for that is 1, and then it will reset those values basically from 0 to 4. So how do we do this? Well, if we go back in here, our particle ID here, we want to make float from int. Yeah, that's fine. We want to do a modulo int first. Modulo int. So this is going to be our particle ID, and then the modulo value is going to be our spawn count. So if I change this and do spawn count, and if I just play again, the particles spawn, and then the next set of particles to spawn are going to be in the same place as well. So if you wanted to have 2 bursts, one sort of quickly after the other, and we'll just do the same number in each case. Spawn count, let's say count 5 seconds, it's going to be picked up automatically. So yeah, just to recap a few bits. When you're dealing with very sort of complex math like this, Niagara's input sort of system isn't the easiest thing to see what's going on. So don't be ashamed to sort of make multiple steps, or just write it out on paper, work out the sort of individual bits. You could see I got lost a little bit earlier as well. Obviously it happens, but just trying to sort of work out what's what, and seeing the sort of the math on these things. So so main thing we're doing is using a rotate vector, and we're using the fact that the particles have this inbuilt numbering system in the spawn, in this case unique ID, using a modulo to reset that so that we're always getting the values between 0 and whatever the local maximum is, in this case 9, and then using that as a sort of multiplier. So we're taking your value, because we're rotating around the x or around the z axis, multiplying it by, in this case it says rotation rate, it's actually just a multiplier for this. It's only a rate when you're using time, so maybe it's a bit of a misnomer, but yeah, that should be all the bits that you need. Cool. Just double check everything works, so we can do bigger angles, smaller spawn counts, different speed and direction. One thing to note, if you put a bigger than 1 or a bigger than unit length vector in here, you will get speed sort of multiplied into that. Now maybe we want to sort of allow that, but personally I think you probably want to take that value and just normalize it, and then we can do our direction vector. So that's just ensuring that whatever input gets put in here, we're always only taking the directional part, because we've got speed down here. Just good practice. It just means that if someone accidentally tries to use direction or speed in the direction vector, and then someone else doesn't, you don't get kind of crosstalk. You're making sure that each thing's only doing exactly what it's supposed to be doing. So okay, I think that's everything. We've got the end result that we wanted. We've just broken it down, and say using the particles ID as a multiplier, rotating with this direction vector by this value, and then just a little bit of sort of converting, so converting floats to ints, and subtracting the sort of like the half width, should give us what we want. So again, thanks very much for the question. Hopefully that has been interesting and helpful. As always, do support me on Patreon, like and subscribe, all of those things. If you do have your own questions, please feel free to write them in. I will do my best to help, and as I say, if it's something interesting like this, we might get a little video out of it as well. So yeah, until next time, yeah, see you then.